Hello everyone, and welcome to this intro to visualizing your data in Python. We're not going to focus on accuracy only, but rather how we can apply visualization to both our input data, i.e. datasets, and our output data, i.e. loss and accuracy. Thus, we're not going to cover the ins and outs of machine learning models, but instead on what we can do with the data we give and get from them. So, why visualize? Well, one reason would be clarity, i.e. it helps you wrap your head around either the data you have or the data your model is sending you. Another important reason is to help with identifying problems, i.e. it helps you spot issues that could affect the performance of your code. And of course, because it's pretty, it'll make your data and benchmarking much more readable to look at, and why wouldn't you want that? Let's say we have some data on meteor landings, for instance. We can start by using the head method on the result of a pandas read CSV call. Right away we spot a value missing. This could affect how we approach our model. Maybe some rows need to be removed or a new dataset entirely is needed. We ought to check and see how many more values are missing. Let's say we also noticed a second label, unknown, being used in the dataset. We'll convert that to nan and then count how many are affected, and which values specifically. By using a pie chart, we can determine which parts of the dataset are worst affected. Removing only the rows with nan values in the top 3 would eliminate most of our empty data, thus reducing potential inaccuracy. We can also adjust which features we focus on in our model based on this information. This is all thanks to visualizing our data. Another pain point in datasets is when, perhaps unknowingly, you might be matching against hundreds of labels, most of which you have very little data for, thus reducing efficiency of your model. By visualizing our data, we can decide which labels to focus on, thus resulting in proof of concept code that actually has reasonable accuracy. Sometimes putting your achievements into context is the best way of realizing what you need to do next. A bar chart will always be more meaningful than two numbers side by side. Let's apply data visualization to another dataset, this time the digit dataset. We first would want to make sure that we are able to process these images, thus confirming that we are handling the right bits of data. We can also use visualization to check if we are overfitting. An overfit occurs when our model sticks too closely to the training data and thus is unable to adapt to new data it receives, and so increasing the loss, i.e. how far to the true value of the model. On the whole, these images suggest we are not overfitting. A more fun use of visualization when processing images is to multiply each pixel by their weight, thus showing us which parts of the image the model focused on. It also looks pretty cool. So far, we've mainly focused on matplotlib, which is fine for using alongside your code. But wouldn't it be great if we could have our graphs visualized in a more portable manner and with more easy-to-use controls and style? Look no further than Dash. It's a Python framework for web apps that allows for highly customizable user interfaces and interactions. While the example I'll show you is neither of those things, it demonstrates how you can get started with Dash. This example is based on Dash's live model training demo, but boiled down to the essentials. It allows for visualizing accuracy of a model over time, simulating a live model by running over a CSV file of steps and showing them one by one. This demo could easily be extended to then compare two different models as if they were training at the same time, and all sorts of other useful analytics. I'll be providing an overview of how the simplified demo is structured, but I would strongly recommend going to Dash's documentation and reading for yourselves how Dash works. We begin by getting some requirements for this project. The demo from Dash also includes some helper functions to easily integrate your own models into this. Requirements-wise, some of these you will most likely already be using, and of course we need to use Dash itself. The two helper functions provided by Dash are add_eval and write_data. The first sets up the evaluation metrics for accuracy and loss, while the second does the heavy lifting for generating a CSV file, i.e. a file with comma-separated values. Next, we import our dependencies into our project, including the core components, containing some components for interactive user interfaces, and HTML components, used for creating the layout of the web page directly in Python. Dash also has a feature called callbacks, which essentially allow for functions to be executed when an input is changed, sending this to an output element in our layout or data. We'll look at those in a bit. Next, we have a function that creates two divs. Think of these as generic objects, one for the current accuracy values and one for the graph itself. Now we can define the layout of our overall page containing a graph and define some stores and intervals for Dash. Stores essentially allow us to store some JSON in the browser and interact with it in an easier manner, while intervals fire their callbacks periodically and thus can be used as internal clocks in our application. We'll also define a function for updating the graph that creates two lines on a graph based on the training accuracy and validation accuracy. Using callbacks, we'll update our log interval, triggering another callback we'll look at later, and we'll also want to update the graph when new steps need to be shown. When this happens, we also want a callback to update the current accuracy values. Now onto the other callbacks we're using. Before a request for the page is received, we want to load our data from the CSV file in the data directory. As our interval for simulated steps increments, we want to progressively include more of the full data on the graph. Thus, we specify a section of the CSV file to show. Finally, when our log interval gets set, we want to check if our data is ready, and if so, update the log store, thus triggering the graph to update. For reference, this is what the CSV file looks for that I was using. To see how to integrate those helper functions, we'll return to the digits dataset. This is using TensorFlow 1.x code, but it shouldn't be too difficult to port this to other machine learning libraries. Once you have a placeholder and a prediction value, you can call add_eval. Technically, I've already done something similar to what add_eval does in the above sections of code, so this can be used to shorten our code slightly. Then, per iteration, we can call write_data to update our CSV file. Note that it'll only save the last epoch in my code because we are using the index in range iterations that gets reset for each epoch. The end result looks something like this. Of course, far more complex things can be made. Take a look at all the Dash examples on their website. This is just a simple example, but it shows you how to get the basics in Dash working together. That's the end of this intro to visualizing your data in Python. Thank you for listening.